Okay, so this lesson is on limiting reactants, and first we need to define two things. So first we're going to define limiting reactant. And a limiting reactant is a substance which is totally consumed when the chemical reaction is complete. So it's totally consumed when the chemical reaction is complete. So you always have a limiting reactant and you will have an excess reactant. And an excess reactant is just like what it sounds. It's the substance that is left over when a chemical reaction is complete. So those are the two definitions that you need to know. Now we're going to look at an example, but I'm going to do the example first regarding grilled cheese sandwiches, and then we're going to take that example and set up an actual equation the same way. So your problem here is that you have 16 pieces of bread, and 5 pieces of cheese, to make grilled cheese sandwiches. You need to solve, or I want to know how much product you will make. I want to know what your limiting reactant is. And I want to know how much excess or unused of your other reactant will be left over. So I'm going to write, what amount of excess reactant will you have? Okay, so even though this is about grilled cheese sandwiches, it is set up very similar or almost exactly like the problems that you will be solving. So first thing you need to pull out is what are your two reactants. So these are basically your ingredients, and your two reactants are bread and cheese. Your product is a grilled cheese. Alright, so out of your reactants, you've got bread and cheese. Out of those two things, one of those things is going to be your limiting reactant. I'm just going to write LR. One is limiting reactant, which means it gets used up. And the other thing is going to be your leftover or excess. Meaning that once all of your limiting reactant or all of your, whichever reactant is limiting, whenever all of that is used up, you are going to have your other reactant left over. You're going to have some that's going to be excess. So once you have figured out that you've got your two reactants and your product, you need a balanced equation. And this is so that you can go back and use your mole ratios. So our balanced equation is 2 breads, or 2 pieces of bread plus 1 cheese, equals 1 grilled cheese. Okay, so now that we have all that information pulled out, we are ready to solve to figure out what our limiting reactant is. So you basically have to set up 2 stoichiometry problems or 2 conversions with each of your reactant and figure out which one is going to limit your amount of product. So if you look in the problem, you have 16 pieces of bread. That's one amount of one of your reactants. 5 pieces of cheese is another amount of another one of your reactants. So we're gonna use each of those to set up 2 different conversions. We're gonna start with 16 pieces of bread, and I want to figure out how much product it's going to give me. So I set up my conversion. Bread, you need to match your units diagonally, and so this I want my mole ratio of how much bread to how many grilled cheese. So I have 2 bread to 1 grilled cheese. So 2 bread to 1 grilled cheese. So if you multiply that out, 16 times 1 divided by 2, that is going to give you 8 grilled cheese. Or 8 of your product. Okay, so now we're going to look at the other reactant, 5 pieces of cheese. And do the same thing, figure out how much product you're going to get, so match units diagonally. If you look, you have 1 cheese to 1 grilled cheese. So we've got 1 cheese to 1 grilled cheese. And if you multiply that out, that's going to give you 5 grilled cheese. Okay, so you look at those 2 numbers. You have 8 grilled cheese, you have 5 grilled cheese. Whatever makes the smaller amount of product is your limiting reactant. Okay, so 5 is a smaller number. And so because that's smaller, that means that the reactant you started with is your limiting reactant. Meaning that that's the one that's going to get used up. So cheese is your limiting reactant. That means bread is your excess. And that means your bread is not going to get all used up if you start with 16 pieces of bread and 5 pieces of cheese. So then we can take this to figure out how much bread you actually use to figure out how much bread is left over. Okay, so I'm going to get a new page. We're going to start with our 5 cheese. And on this one, I want to figure out how much bread I'm actually going to use if I use up all of my limiting reactant. So cheese goes on the bottom. And I want my cheese to bread ratio. So I have 1 cheese for every 2 breads. So that means in this reaction, if I start with 16 pieces of bread and 5 pieces of cheese, I will make as many grilled cheese as I can, which is going to use up all of the limiting reactant, which is your 5 pieces of cheese, and 10 pieces of bread. Oops. Bread. So this is how much bread is used. Okay, most of the time it's going to ask how much excess or how much left over do you have. So that means that we started with 16 pieces of bread. We used 10 pieces. So that means when the reaction is all done, or when you're done making grilled cheese sandwiches, you will have 6 pieces of bread left over, or excess. Okay, so I know that seems silly to do this whole reaction with grilled cheese, but you'll see in the next example that you are actually setting it up almost exactly the same. So if you get stuck, refer back to this. But we're going to do the 2 examples on the front of the worksheet that you should have gotten. Alright, so your first problem says when a mixture of silver metal and sulfur is heated, silver sulfide is formed. Your equation is given, and first step to solving stoichiometry problems is balance the equation, and it is already balanced. So it says what mass of silver sulfide is produced from a mixture of 2 grams of silver and 2 grams of sulfur. So you've got your 2 reactants. And I'm assuming this is meaning S8. You've got your 2 reactants, and so you've got to figure out, starting with one of your reactants, how much product will you make, and starting with your other reactant, how much product you will make. And that will help you determine which is the limiting reactant. So we'll start with the first one, given 2 grams of Ag. And remember, when we're doing stoichiometry problems, it has to be in moles. So you have to convert from grams to moles before you can do a mole conversion. So we've got grams, we got to get to moles first. So grams Ag on the bottom per 1 mole Ag. And silver has a mass of 107.9. So from there, your grams Ag will cancel out. You are in moles of Ag, and we want to figure out what the mass of Ag2S is going to be. So first we have to convert moles Ag to moles Ag2S. This is where you use your mole ratio. And so if you look at your balanced equation, you have 16 moles Ag for every 8 moles Ag2S. So moles Ag goes on the bottom, 16 mole Ag for every 8 mole Ag2S. Okay, from there, your units cancel out, moles Ag cancel out. It is asking for mass. So we have to do one last step, just like in your mass-to-mass problems that you did yesterday. 1 mole Ag2S goes on the bottom. And your mass, your grams of Ag2S goes on top. So that's your 107.9 plus 107.9 plus the mass of sulfur, which is 32.1. So it should be, the molar mass should be 247.9. So your units cancel out that are diagonal from each other. And so you should solve this. Your final unit is grams Ag2S, and that's what it is asking. So if you start with 2 grams of Ag, you should get with 2 sig figs 2.3 grams Ag2S. Okay, so that's if you start with 2 grams of silver. Now we have to start with our other reactants, so 2 grams of S8. And we're going to try to figure out how much product this will give us. So again, taking your grams, converting it to moles. So you have grams S8 per 1 mole, S8. Sulfur, again, has a mass of 32.1. Times 8 is 256.8. The units that are diagonal cancel out. Now you're in moles of S8. Now you can do your mole ratio. So you've got moles S8 on the bottom, 2 moles Ag2S on top. And if you look at your balanced equation, it is 1 to 8. So 1 S8 for every 8 Ag2S. Moles S8 will cancel out. And then your final step is to get mass of Ag2S, because that's what it is asking. So it's going to be your 1 mole Ag2S for the mass, the molar mass on top, which is the 247.9 grams Ag2S. And then solve that problem. Here I got 2 sig figs, so just 15 grams Ag2S. Alright, so if you look, whichever one produced less product is going to be your limiting reactant. So this is our smaller product. That means whatever you started with is your limiting reactant. That means silver is our limiting reactant. So if that's our limiting reactant, that means our silver gets completely used up. So there is going to be leftover S8. So it says what mass of which reactant is left unreacted. So you have to take your limiting reactant and figure out how much mass of S8 it is going to use, and then that can help you figure out how much is going to be left unreacted. So we're taking our limiting reactant, 2 grams Ag, and we're going to try to take it to grams of S8 because we want to figure out how much it's going to use up. So again, take it to moles. Once you get it to moles, we're going to use our mole conversion. We're going to be going from moles Ag to moles S8. If you look up at the top, you have 16 moles Ag to 1 mole S8. 16 to 1. Your moles Ag will cancel out. Now you're in moles of S8. You need to get to grams of S8, so you need 1 mole S8 to your molar mass, which we figured out before was 256.8. Mole S8 cancels out, and then we solve. So I got point in, let's see, 2 sig figs. 0.279, so it's going to be 0.30. And this is grams S8. And that's how much is used. You start, so you're going from your 2 grams of silver, which is your limiting reactant, to figure out how much S8 it is going to use in the reaction. 0.30 grams used. It is asking for how much is left unreacted. So that means you need to take how much you start with, which is 2 grams. And you need to subtract how much you use, which is 0.30 grams. So you are left with 1.70 grams S8 left unreacted. And notice with sig figs, oh, I did do it wrong. Okay. Just kidding. It's just 1.7. There we go. Okay, so there you've solved it. You figured out your limiting reactant. You figured out how much excess is used, so therefore how much excess is left unreacted. Your second example, aluminum burns in bromine producing aluminum bromide. It gives you the balanced equation. I'm just going to kind of get you started, but you should be able to follow the last one to solve this one. So you've got your 2 reactants, aluminum and bromine. Remember, this is your Al, this is your Br2. And so you have to take each of those reactants, and you're going to be setting up 2 conversions like before. And so your first conversion is going to be going from 6.0 grams of aluminum, and you need to get it to, or you need to convert it all the way to grams of aluminum bromide. And then your second conversion, you're going to be starting with 39, just 39 grams of Br2, and you're going to be converting it to grams of AlBr3. And whichever one produces the smaller number, that will tell you what your limiting reactant is, and that smaller amount is also going to be your total product produced. So that's going to answer the second part of the question. So work through this one, check the people around you. You can check with my answer key, and then flip it over and try to get through as many as you can on the back, or at least parts of them if you can get through parts of them.